depth of education, let us look at some revision questions on qualitative analysis, that's ionic chemistry and qualitative analysis. So let us try to see how we can go about with this number here. It helps us only not in practical, but also in paper 2 theory, and also paper 1, that is also theory. So let us look at this kind of paper 2 type question. That is in this case it is a structured question. A mixture of zinc sulfate and zinc carbonate. Let us be analyzing together. A mixture of zinc sulfate and zinc carbonate was shaken vigorously with excess water and filtered. We should identify the anion in the residue and in the filtrate. You see, this process of shaking a mixture with the water, in this case vigorously, and then filtering, that one is just to make sure that you separate the two salts. In this case we are separating them, but in this mixture one of the salts is soluble in water and another one is insoluble in water. So it makes me go for a simple summary here, which we need to look at. Soluble and insoluble salts. The soluble and insoluble salts. This one will help us a lot in trying to answer such a question. You need to have a clear knowledge of the soluble and the insoluble salts. So these salts, we are going to have them in their categories of the sulfates, the chlorides, the carbonates, and then the nitrates. I want to start with the sulfates. So only barium sulfate, lead sulfate, and calcium sulfate, in this case, are the insoluble sulfates. And we need to remember that calcium sulfate is sparingly soluble. That means it dissolves partially. It can dissolve but not fully, but slightly or partially. So barium sulfate, lead sulfate, and calcium sulfate are the insoluble sulfate salts. Meanwhile, calcium sulfate, which is among these insoluble sulfate salts, is just sparingly soluble in water. Then we go to the chloride salts. A simple summary here. Only silver chloride. We have silver chloride, and then lead chloride, are the insoluble chlorides. And we should know that lead chloride is having a high solubility at a high temperature and a low solubility at a low temperature, meaning that lead chloride can dissolve in hot water, or when the mixture or a solution in which it is heated, then it will simply dissolve on heating. And even when it cools down, then you see the precipitates reappearing, meaning that it has a high solubility at a high temperature and a low solubility at a low temperature. So we are mentioning in each category of the salts members which are fewer in a category. Like in this case, the insoluble sulfates are lesser in number. So we mention them and we say the rest of the sulfates are soluble in water. Even here, we have only silver chloride and then lead 2 chloride, which are the insoluble chlorides. There is also one which is mercury 1 chloride, but it is not very common. But the common ones are these ones here, silver chloride and lead 2 chloride, which we normally meet them in the laboratory. They are the common insoluble chlorides, meaning that the rest of the chloride salts are soluble in water. And we have also added here that lead 2 chloride dissolves in hot water. Then let us go to the carbonate salts. We have only potassium carbonate among the common ones. We have the potassium carbonate, we have sodium carbonate, and ammonium carbonate, are the this time soluble carbonates, meaning that they are the ones that can dissolve in water. The rest of the carbonate salts do not dissolve in water. So these are the 3 common soluble carbonates. So let us go to the last category, that is the nitrates. We have all nitrates being soluble in water. So all nitrates are soluble in water. There is no any insoluble nitrate salt. So all nitrate salts are soluble in water. So a candidate is supposed to be able to remember this, and remember that for the insoluble salts, any one of them formed as a result of a reaction between 2 solutions, or maybe between a solution and a gas. If any one of these insoluble salts is formed, it will be formed as a precipitate, because at no point or at no time at room temperature will they be solutions, since they are insoluble in water. So they will be precipitated, and such a reaction, we learned that it is what we call a precipitation reaction, or what we call double decomposition. So these are the soluble and the insoluble salts that we don't have to forget. Now let us try to look at this question here. A mixture of zinc sulfate and zinc carbonate was shaken vigorously with excess water and then filtered. So I say that the process of shaking with water is to make the soluble component of this mixture to dissolve, and it should leave behind the insoluble component as a solid. So when you filter, in the filtrate you'll be having the soluble component of that mixture excuse me, while in the residue you'll be having the insoluble component. So let us try to analyze them from here. Zinc sulfate is a sulfate. We know that it's only barium sulfate, lead 2 sulfate, and calcium sulfate, which are the insoluble sulfates, meaning that zinc sulfate is soluble in water. And then zinc carbonate, let us see here, potassium carbonate, sodium carbonate, and ammonium carbonate are the common soluble carbonates, meaning that zinc carbonate is insoluble in water. So for this reason, when we shake vigorously with water, as we saw yesterday, and then we filter through a filter paper, we are going to get a residue which will be containing zinc carbonate, since it is insoluble in water, and then zinc sulfate will come out as a filtrate, since it is soluble in water. So now they are saying, identify the anion. That means they don't need the whole of the name of the salt. They only need the name of the anion. They only need the anion. So when they say you identify, you are free to either write the chemical formula or you give the name of that particular substance. But should they say name, don't give the formula, just give the name. So here we have been told to identify the anion in the residue and in the filtrate. So we can either name or we give the, in this case we can name or we give the chemical formula. In the residue we have the carbonate ion. So let us use the chemical formula of carbonate ion, or we can even use the name. And in the filtrate we have the sulfate ion, SO4 2 minus. The dry residue was heated strongly until no further change. State what was observed and then write equation for the reaction that took place. Good. If you have a question like this, where you need to start by giving the observation and then later on you write the equation for the reaction, how I wish you could start with the reaction equation to give you, in this case, what to write as your observation. So we are going to first write the equation for the reaction, see the products, and then we come back here and we state our observation. So the equation for the reaction is between it is all about the thermal decomposition of the residue. The dry residue was heated strongly until no further change. So our residue is zinc carbonate. It was heated strongly. So when it decomposes, it gives us an oxide, which is zinc oxide, and then the gas is carbon dioxide gas. So this is our equation for the reaction. Now we are going to the observation. In our observation, we know that this is zinc carbonate, and carbonate exists as a powder. So in this case, the zinc carbonate will be decomposed into zinc oxide and carbon dioxide. Now, carbon dioxide is a gas which we know that turns lime water milky. Please, that one is strictly impractical. When it comes to a theory question like this, we need to give the real name of the lime water, which is calcium hydroxide solution. And then why the lime water turns milky is due to the formation of tiny solid particles of, in this case, calcium carbonate. So we have to talk of the precipitation of that calcium carbonate, the formation of white precipitate when you pass the carbon dioxide gas through the calcium hydroxide solution. And then zinc carbonate is a white powder, and then it turns into a residue which is zinc oxide, and this zinc oxide is a residue which is yellow when hot and white when cold. So we shall be able to get the white powder. I'm talking now of the zinc oxide. The zinc carbonate. The white powder formed a residue which is yellow when hot and white when cold. A residue which is yellow when hot and white when cold, and a colorless gas which forms a white precipitate with calcium hydroxide solution. So here we have talked about the carbon dioxide gas, a colorless gas which forms a white precipitate with calcium hydroxide solution. I have not said that a colorless gas which turns lime water milky, no, because that one is supposed to be for our practicals. Now write equation for the reaction between the solid product in B and dilute hydrochloric acid. So it is zinc oxide, which is our solid product, and it is reacting with the dilute hydrochloric acid. So this one gives us zinc chloride solution. It also gives us water, and it gives us carbon dioxide gas. So we balance the equation. There are 2 atoms of hydrogen, multiply hydrochloric acid, 2 atoms of chlorine, they are the same. Our equation is balanced. Name the reagent that can be used to identify the anion in the filtrate. The anion is sulfate ion. So the reagent is barium nitrate solution and dilute nitric acid. State what would be observed if the filtrate was treated with the reagent you named in C Roman 1. So here we are having barium nitrate solution and dilute nitric acid. We would be able to get a white precipitate, insoluble in the acid, as we saw earlier on. Then the ionic equation for the reaction. So the barium ion of the barium nitrate solution will combine with the anion in the filtrate, which is the sulfate ion, and we get barium sulfate. So that is our ionic equation for the reaction. I believe that you enjoyed